In Christopher Nolan's Interstellar, one of the most mind-bending concepts is the time dilation experienced on Miller's planet. Every hour spent on this water world cost the crew 23 years back on Earth. But why does this happen? The answer lies in one of Einstein's most fascinating theories. When Cooper and his crew approach Miller's planet, they're warned about something extraordinary. Brand explains that the planet orbits dangerously close to Gargantua, a massive black hole. She delivers the shocking news: every hour they spend on that planet will be 7 years back on Earth. Cooper immediately grasps the implications. He argues that Plan A won't work if everyone on Earth is dead by the time they return. Brand reminds them they need to think of time as a resource, just like oxygen and food. To understand why this happens, we need to explore Einstein's theory of general relativity. According to Einstein, massive objects like planets and stars warp the fabric of space-time itself. Romilly demonstrates this beautifully when explaining wormholes to Cooper. He shows how space can be bent, creating shortcuts through higher dimensions. But Gargantua isn't just any massive object, it's a supermassive black hole. Romilly describes it as having unbelievable gravitational forces. He calls it a literal heart of darkness, so powerful that not even light can escape its horizon. Here's where it gets fascinating. Gravity doesn't just pull on objects, it pulls on time itself. The stronger the gravitational field, the slower time passes relative to areas with weaker gravity. Cooper even acknowledges this when explaining the mission to Murph, telling her that time will run differently for them. Miller's planet sits on the edge of Gargantua's immense gravitational well. Romilly describes it as being like a basketball spinning around a hoop. This proximity to the black hole creates extreme time dilation effects. As Cooper pilots the Ranger down to Miller's planet, they're racing against time itself. He pushes the craft to its limits, using aggressive aerodynamic maneuvers to save fuel and precious minutes. Brand protests that they're going too fast, but Cooper knows every second counts. When they land, they make a devastating discovery. The planet is nothing but water, with massive waves towering in the distance. What they thought were mountains are actually enormous tidal waves created by Gargantua's gravity. They find the wreckage of Miller's lander, and Case reveals the heartbreaking truth. Miller didn't land years ago. Due to the time dilation, she arrived just hours before them. Brand realizes Miller probably died just minutes ago in their time frame. The data they'd been receiving was just her initial status signal echoing endlessly. But they don't have time to process this. A massive wave is approaching. Brand insists on retrieving Miller's data, refusing to leave without it. Cooper desperately orders her back to the Ranger as the wave looms closer. In the chaos, Doyle is swept away by the massive wave. The Ranger's engines are flooded, leaving them stranded as another wave approaches. They barely survive the second wave, their ship tossed like a toy. Cooper has to drain the engines and wait precious minutes before they can restart. Brand demands to know how much time this disaster will cost them. The answer is devastating: decades. When they finally return to the Endurance, Romilly has been waiting alone. He tells them he's waited years, having given up believing they would return. Case delivers the precise calculation: 23 years, 4 months, and 8 days have passed. Cooper faces the consequences when he watches decades of messages from his children. Tom grows up, gets married, has children, and loses his grandfather, all while Cooper was gone for what felt like hours. By the final message, Tom has given up hope that his father is even listening. Then Murph appears, now the same age Cooper was when he left. She reminds him of his promise that they might be the same age when he returned. It's a heartbreaking moment that shows the true cost of time dilation. What makes this science fiction scenario so powerful is that it's based on real physics. Einstein's equations of general relativity predict exactly this kind of extreme time dilation near massive objects. The movie's scientific consultant, physicist Kip Thorne, ensured these effects were portrayed accurately. To put this in perspective, GPS satellites orbiting Earth experience measurable time dilation. They're farther from Earth's gravity, so their clocks run slightly faster than clocks on the surface. Miller's planet takes this effect to an extreme because of Gargantua's immense mass. So how exactly does gravity slow down time? Think of space-time as a flexible fabric that can be stretched and compressed. Near a massive object like a black hole, this fabric is severely warped. This warping affects not just the path objects take through space, but also their path through time. At the event horizon of a black hole, time dilation becomes infinite. From an outside observer's perspective, anything falling into a black hole appears to freeze at the horizon. Miller's planet orbits just outside this point, experiencing tremendous but not infinite time dilation. This phenomenon has profound implications for the mission. Cooper realizes they can't afford to visit all potential planets because of the time cost. Every decision becomes a calculation of not just fuel and resources, but years of Earth time. Later, they use Gargantua's gravity to their advantage in a desperate slingshot maneuver. Cooper warns that this maneuver will cost them 51 more years. He jokes about being 120 years old, but the reality isn't funny. The genius of Interstellar is how it makes abstract physics deeply personal. Time dilation isn't just an equation, it's a father missing his daughter's entire childhood. It's the agonizing choice between scientific duty and family. Brand later argues that love itself might transcend dimensions. She suggests it's something that can reach across time and space, just like gravity. In a universe where time is relative, perhaps emotional connections are the only constant. This idea becomes crucial when Cooper falls into the black hole and enters the Tesseract. There, he experiences time as a physical dimension he can navigate. He realizes that beings from the future created this space, allowing him to communicate across time through gravity. Using the second hand of the watch he gave Murph, he transmits quantum data through gravitational manipulation. It's a brilliant narrative device that brings together all the film's themes about time, gravity, and love. Ultimately, Murph receives the message and solves the gravity equation. But by the time Cooper wakes up near Saturn, he's aged only slightly while Murph is now elderly. She tells him no parent should watch their child die, reversing the natural order of time. Miller's planet serves as more than just a plot device in Interstellar. It's a powerful demonstration of how Einstein's relativity affects time itself. The extreme time dilation occurs because the planet orbits so close to the supermassive black hole Gargantua. Gargantua's immense gravity warps space-time so severely that time literally runs slower on the planet's surface. What makes the science beautiful is that it's real. These effects exist in our universe, just not usually at such extreme levels. The film reminds us that time isn't the steady tick of a clock we imagine. It's flexible, relative, and intimately connected to gravity and space. And sometimes the cost of exploring the universe is measured not in distance, but in the years we can never get back.